How does AI came to be? Believe it or not, AI is not new. Our journey began in 1956 at the Dartmouth Conference where the term artificial intelligence was coined. But since then, we have witnessed incredible milestones from AI defeating a chess champion in 1997 to breakthroughs in computer vision in 2012, and leading to AI ability to learn and detect objects in photos. And then you have creative AI generating art and music in 2018. Of course, around 2020 is the unmissable appearance of ChatGPTs, or more in a bit term of like generative AI, has the ability to understand and generate new content from text-based to multimedia content like images, audios, videos. And then we can fast forward to today in 2024, with the focus is actually on creating AI that is ethical, safe, and transparent. So this timeline shows us that AI isn't just a sudden intervention. Decades of research coupled with leap in processing powers, data availability has moved AI from science fiction towards to everyday tool. Now, many people might wonder if AI equal robot taking over the world. Well, AI is more actually about teaching machines to learn from data and make decisions. For instance, an image classification models simply identify which photo contain cat. This is about finding pattern, not planning world dominations. Now, let's break down the core process of AI. So at its heart, AI take in data, analyze it, and find pattern, and then make predictions. While AI might contain algorithm and automation aspects, one might not mean the others, so it is important to distinguish and understand these separately. First, think of algorithm as the blueprints, a set of steps to solve a problem, much like a cooking recipe, a series of set of steps to cook a meal. Automations use that blueprint repeatedly. So if you can imagine like a machine factories running at the same instructions over and over again. But AI go further. It does not just follow instructions. It also study as it's automate. It keep learning from the large amount of data to make new decisions or predictions. It constantly updates its approach based on its learn. So in short, AI builds on the notion of structured step from algorithm. It automates step, but it differ in adaptability. So before we detail the inner working of AI, so this will introduce two aspects that are very much involved with this process. The first one is analytical thinking. What is it? So this type of reasonings involve breaking problem down into smaller parts. In an educational settings, one might break down a complex research question into simpler segments, a small hypothesis, for example, like investigating user behaviors and then exploring the technologies that addresses those behaviors. So AI development follow these patterns by deconstructing tasks into data gathering, pattern recognition, and then prediction. Moving on, we have structural thinking. Now, this is about putting those smaller pieces in the proper orders. So using a recipe as an example, if you line up all the ingredients that you have, now you need to follow certain step in a logical sequence. In AI, the system must handle the input, processes, produce an outcome, and then learn from the feedback. If these steps are out of orders, the system fails. So imagine trying to train a chatbot even collecting the relevant text data. The structures help ensure each stage connect effectively to the next. So together, these two skills help us design and troubleshoot AI system effectively. When you're building or refining an AI-based learning app, it's important to first break down its function, and then second, arrange them so that they use the data collections, model trainings, and result feedback form a sensible loops. If we skip any step, the system might produce incorrect or incomplete response. That is why AI projects require both detailed analysis as well as step-by-step organizations. So, in short, AI daily operation would contain these four main steps. First, data collection. Second, learning from those data. Then, making predictions. And lastly, improving over time. So let's put these ideas into a bit more practical context. So consider scenarios where we want an AI to identify fruit. First, we collect thousands of images of apples, bananas, and orange. Next, the AI will look for patterns. So apple might be round and red, banana might be long and yellows, and orange, well, they have their own distinct features. The AI then uses this pattern to predict the identifiers of new images. And if it make a mistake, we corrected it, and then the system will learn from that error. This is how AI get better over time. Now, let's talk about the two important subset of AI, machine learnings and deep learnings. First, what I meant by subset, in simpler terms, we can say that all machine learning and deep learning application is AI, but not all AI is machine learning and not all AI is deep learning. So at a higher level, machine learnings involve algorithms that learn patterns from data, which on the other hand, deep learning is a subset of machine learnings that is neural network, structures inspired by the human brain to learn complex patterns automatically. Now, while machine learning can work with smaller data set and is often requires some human input in selecting the features, deep learning thrives on huge dataset and it can discover intricate patterns on its own. Each has its own strength and ideas use case, whether it is predicting house price or powering self-driving car. So in that sense, we can see example like predicting house price or even recognizing a handwritten digit. This might be handled well by machine learnings, but to distinguish complex objects in image and speech to text, self-driving car, this actually call for deep learning.